This video is a review over sections 2.5 and 2.6, solving limits algebraically. Alright, good news is we're done with estimating limits by making that table and plugging in values closer to our point of interest, because solving limits that way took like 12 years and no one liked doing it that way. So, done with that. But bad news is now we're on to more actual math kind of things. And these problems can be pretty tricky the first time you see them. You're not entirely sure where to start. So hopefully after we go through this roadmap, we'll have a better understanding of how to approach these types of problems and know where to start. Alright, so let's go through this. Solving limits algebraically. Our first step is to always try direct substitution. That means we take our point of interest, plug it into our function, see what happens. One thing that could happen is that we get a valid answer. We get a number, that's our limit. If that happens, woohoo, you're done. That's the end of the road for you. But what's much more likely to happen is that we plug in our point of interest into our function and we get something called an indeterminate form. An indeterminate form is not a valid answer, it's illegal. It's either something like infinity over infinity, 0 over 0, or infinity minus infinity. If you get one of these values after you try direct substitution, that's indeterminate, not a valid answer, gross. That means that we need to do more work. Fun. And what kind of work do we need to do? Well, we're going to take our function and try to simplify it. Hopefully something will cancel out, or we'll be able to see it in a new way, so that when we try direct substitution again, we'll get a valid answer. Okay, and this is where the section gets really tricky, because there's so many different types of functions that it's hard to know how to simplify it. So we're going to go through 3 really common types of functions that you'll see, and the first steps you should do to simplify them. Alright, so if we have an indeterminate form, let's go through the types of functions we might have. We might have one with complex algebraic expressions. If we have one of those, we're going to simplify it by factoring. Alright, so for example, if you have something like this with an x squared term, this is a quadratic. If you remember, you can simplify a quadratic by simplifying it down into 2 binomials. So when you simplify this out, you get x minus 6, x plus 1. And if you were to FOIL that out, you'd get back to the quadratic that you started with. I have an algebraic review video that goes through more in detail how to solve these types of expressions. But for now, I'll just give a brief overview. Alright, so if you see a quadratic, FOIL it down into 2 binomials. If you see this pattern, something like t squared minus 1, this follows the difference of perfect squares, and this always factors down into t plus 1, t minus 1. Alright, and third type of algebraic expression you might see is if you have a bunch of fractions in your function. If you have a bunch of fractions, more often than not, it'll make it a lot simpler if you combine the fractions. And remember, in order to do that, to add or subtract fractions, they need to have a common denominator. So if we had something like this, where it's 2 over ac minus 4c over a, we'd have to multiply this by c over c, get a common denominator. And when we do that, we're able to subtract the top, and we get 2 minus 4c squared all over ac. Alright, those are some common complex algebraic expressions that you might see. Be sure to be familiar with how to simplify quadratics and difference of perfect squares. Those come up a lot. Alright, next type of functions we might see is if it has trig in it. Whenever we see trig, first thing we always want to do is rewrite it in terms of sine and cosine. Brief review, if you have something like secant, secant can be rewritten as 1 over cosine x. Cosecant can be rewritten as 1 over sine x. And tangent x can be rewritten as sine x over cosine x. Alright, once we've done the first step, we've rewritten the entire function in terms of just sine and cosine, like this. Our next step is to make our function match an identity. If you remember in section 2.6, we had 2 identities, one for sine functions and one for cosine functions. They said that the limit as x approaches 0 of sine x over x is equal to 1. And for cosine, the limit as x approaches 0 of 1 minus cosine x over x is equal to 0. And remember, it doesn't have to be just x in here. It could be sine of something over that same something is equal to 1. And same thing for cosine. 1 minus cosine of something over that same something equal to 0. Alright, so if you see trig, first thing you want to do, rewrite in terms of sine and cosine. Next thing you want to do, try to get it to match the identity. There's one for both sine and for cosine functions. Alright, third type of function we might see is one that involves radicals. Whenever you see a radical, first thing you want to think of is multiply by the conjugate. If you don't remember what the conjugate is, we're going to go through this example and hopefully it'll come back to you. So you have a function like this, rad x minus 4 over 16. Oops, this is supposed to be x minus 16. My bad. We see a radical, we're going to multiply by the conjugate. Multiplying by the conjugate just means you take this expression with the radical, multiply it by the same thing, except flip the sign in the middle. So instead of rad x minus 4, I'm going to multiply by rad x plus 4. I do the same thing on the bottom. Remember with fractions, whatever you do to the top, you have to do to the bottom. Now I just multiply straight across. On the top, when I FOIL this out, I'll get x minus 16. And on the bottom, pro tip, don't actually FOIL these two things out. Just leave them as their factors, and that way it'll be easier to see how things cross out that way. All right, so I leave this as my factors, and I get x minus 16 times rad x plus 4. And conveniently, just like we wanted, we have an expression that cancels out, and now I'm just left with 1 over rad x plus 4. All right, here was a really brief overview over 3 different types of functions that you might have and how to simplify them. Hopefully, as you're going through these problems in section 2.5 and 2.6, this offers a good roadmap of where to start and the first things you should think of when you see them. Hope this was helpful.